Hello everybody, today I want to talk about the BeamCase SFF version 5 update, and with that also the introduction of the micro ATX and full ATX versions of the case. Maybe some of you have seen BeamCase SFF, the previous version, which is a case that focuses on large air coolers within small ITX cases. The version 5 update brings substantial changes to the construction, which also makes the case compatible with smaller printers. From the ground up, for people who don't know BeamCase is a DIY computer case system that allows you to create your own case with combinations of these 15 by 15 Makerbeam XL extrusions and 3 printed brackets, which I'm going to show you in detail more in a second. The version 5 update is pretty big and it's very significant. It rehauls the whole construction basically from the ground up with a lot of additional changes. As I said, it also introduces the ATX and micro ATX versions that people have waited now for a long time. So in the previous version, the back panel looked like this. So it was a singular piece. This is the 2-slot version with a 120mm rear fan support. Now with the new version, the construction is revised and it's always made up of 2 pieces. So there's the top part, which you can see here, and you see how it's not much shorter than this one, but it's a little bit shorter. And you can see here the lower part is missing. That is where the lower brackets come into play, which in this case slide in and then it becomes a 2-slot version. Or like this one here is 4 slots and it's big enough for mATX, and you can attach that. And now, because the panel is split, we don't need a printer that prints the whole thing in one piece, but instead we print them separately and then connect them. And it took me a while to engineer a secure connection between these 2 brackets, but there is now in total 8 screw connections, 2 here on each side and then 4 here in this center, that make sure that these are securely connected. And that's how I'm sure that this connection is strong enough. And I worked on this for quite a while to make sure that this works well, is reliable, and really is up to my standards in terms of functionality and strength. And that's why it took a while to release the ATX version, because I wanted to make sure that this works flawlessly. And now, as you can see in this case, I have attached the 4-slot lower bracket, but as I said, there will be one with 7 slots, and that one will be for the full ATX version. And then, as you just saw, there is the 2-slot one here as well for 2-slot ITX builds, but then it will also be a 3-slot one. So this is the major change with BeamCase version 5, and this rear bracket here will be available in different versions. So for this one I have a clamp-in style PSU extension and a spot for a rear 120mm fan and a spot for a 16mm power button. But there's also the option for a rear ATX PSU, as you can see here. So this will limit your CPU cooler clearance, as there will be an ATX PSU here then, but this way you can use a full size, as I said, ATX PSU, which is pretty cool and gives you a lot more options, especially if you transfer your build from an existing case. And this one also has a spot for a 60mm power button here, but these are just 2 versions, and I will create more in the future with different options. And in the files there's also a template where there's nothing here. It will be a step and a STL, so you can create your own versions of whatever you want to fit here. So let's say you want more buttons, and you can add more buttons, or you want to add a mount for a specific pump, water cooling pump. You could add that here as well. You can easily adjust or customize the step file in a CAD program of your choice. So this is the really big change, where it's now a split construction that enables to have many versions of the top panel and then simply add the corresponding lower bracket to get the correct size for your build. And I have now obviously the 2-slot version here, and then we can compare like the overall size is still the same, and all the basically the dimensions are still the same for the existing version. So the 2-slot ITX version and the 3-slot ITX version still have the same sizes as before, and the mounting positions are still the same. The major update really is about the construction method between version 4.7 and version 5. And actually version 5, even though it is split around here, it is actually stronger because I made the material thicker everywhere. And yeah, what has also changed is the method of mounting the GPU. You will see this later in more detail. Now with the version 5, I've changed to a slightly different system that's inspired by my sandwich style case that I've recently released. So instead of going through the top and trying to secure the nuts here, which is very difficult now that it's split here and there's not a lot of space, you have this bracket which has also space for nuts inserts, and you can secure that here and then screw it in. But I'm getting ahead of myself now because I will show you that later directly as an example on a build. So with this split in the rear panel, it also means obviously that the printer requirements are reduced, as I just mentioned. Since the panel is split now, you only need to be able to print this panel, and it will just barely fit on a standard Ender 3 style printer because the part is around 218 millimeters long, so it will just barely fit on an Ender 3 style printer. And the other limitations are the case panels, and there will also be an option to split them, but I'll get more into detail later. But basically what this means is the new version will reduce the printer requirements overall drastically. Instead of needing a P1S or A1, you can print the whole thing with an Ender 3, which is really cool, and it's also one of the added benefits of the new version 5. So getting at what you need for version 5 in terms of components and hardware to build it. So that's basically the same as previously. In terms of what you need to build it, nothing has really changed. While the structure has gotten a big update, the required parts are still the same. So in terms of maker beams, you need 4 300mm long maker beams or longer ones, which make up the length of the case. And then for the height, you need 200mm long ones for all the ITX versions and for the mATX version as well. But for the full ATX version, you will need 300mm long beams for the height, 2 of those. But you can see the exact requirements in terms of length in the Printables post corresponding one, so you know exactly what you need to buy. The case is not exactly the length of these, but the difference will be made up with different 3D printed brackets. So those will increase the case height with each corresponding version. If you really want to be perfect, you could also get custom lengths of these, but all of the cases I have designed use standard lengths by default, so you can just easily buy them. So that these are for the height, these are for the length. You can also use longer maker beams than 300mm for the length. 300mm is kind of the minimum for most configs, but you can also use 360mm ones to support longer graphics cards. The length of the case is purely defined by these profiles. So if you use 300mm long ones, you get around 350mm of GPU clearance, and if you use longer ones, then you get more GPU clearance. And this is very flexible to whatever you want to do. The only thing is I designed the case panels for the 300mm long ones, but there are also steps for each case panel version, so you can adjust the steps for your case size and then print the corresponding ones. By default it is 300mm because that supports a lot of GPUs, including 4090s and 4080s Founders Edition. So those are the main ones you need. Then optionally you can also use this one, which is a 150mm maker beam with corner cubes. This would be used at the top front of the case, but these 150mm maker beam XL only come in a pack of 4, and these corner cubes only come in a pack of 12, and they cost 25 euros. So this is expensive, and you will have a lot of left over if you just use it for this case. So there are also options for 3D printed replacements. So this is a 3D printed replacement with holes. There's also one with a singular slot, Obviously they don't have fully the same capabilities as the aluminium one. The aluminium one is stronger and you have nice slots on all four sides, so that's still the better option. But if you don't want to buy this because it's quite expensive just for the one you need, you can also use the 3D printed replacement. It's strong enough. It's not as strong as aluminium, but strong enough, and it does what it needs to do. It's also compatible with the SFX power supply mount. So I'm actually going to use the 3D printed replacement today just to show how it works, but you can also use this aluminium version. So that was all that you needed for Makerbeam profiles. And now we're going to go into the screws you require. It's the same requirements as for the previous versions, so there has nothing changed. If you know the previous version, then you will know this one. You will need 8 by M3 countersunk screws with an 8mm length. Those are these. Then you will need M3 countersunk screws with 16mm length. Then you will need M3 nuts, and optionally you can use these flat square M3 nuts and these 3D printed profiles, which secure the nuts in the profile so they don't slide around. These flat thin M3 nuts are totally optional. You don't have to use them, but you need the standard M3 nuts. And then we also have this screw, which is kind of a special screw because it's an American thread style screw. It's 6-32 UNC style screw, and you only need 4 of those. This one is required for the power supply to mount it. Power supplies don't use nice M3 screws, so they use the special American thread, and so you will need to buy those. I normally buy these in a pack on Amazon, so I get multiple lengths at once, because it can be otherwise difficult to find them. I personally use Torx M3 screws. This is the 8mm countersunk M3 screw, and I use Torx versions for both of these, but that's optional. You can kind of use whatever head type you want to use. I would recommend Hex or Torx, but theoretically you can also use a Phillips type head. Yeah, and these are stainless steel, but you can use whatever kind you want. It's totally open to you. It's just they need to be countersunk M3 8mm, countersunk M3 16mm, then this 16-32 UNC thread screw, and that has to have an overall length of around 18mm, around a 16mm thread length. This is doesn't have to be super exact because there is a bit of room in the power supply for longer screws. Yeah, and then a standard M3 nut, and optionally these flat, thin M3 square nuts. And that's all you need to build the entire case, even including case panels, the newer style case panels. Other case panel styles might have different requirements in terms of screws. And then besides screws, you will also need some cables. A 60mm power button is the standard one that's planned for this case, but you can also use different ones with custom brackets. Really, there's no limit to what kind of power button you want to use. You can just create your own bracket, but this is the standard one. I buy these off Amazon and then I sleeve them myself, like this. I have not found them pre-sleeved nicely. I just do it myself, but it's quite easy. And then you need an internal PSU extension. The angle and length kind of depends on your setup. Normally a 30cm one is enough, and I use these that don't have any screw options here at the back. They just get clamped into place, which you will see later. But there's also an option for a standard C14 screw-in type extension as well. This one's angled down like this, but the exact angle in this area will largely depend on how your case is configured. So this one works for the micro ATX case and the full ATX case, but it can also look different. So it highly depends on how you configure a case, because it's so modular. It's not standard. I can't just give you a standard one that will always work. You need to kind of see how your power supply sits within the case. You only need this if you use an internal power supply, like an internal SFX or SFX XL power supply. If you mount the full ATX power supply to the back, then you don't need an internal extension. Then this hole here is not important. Only if you use an internal power supply. Yeah, but it's kind of the only two cables you need, and yeah, that's kind of it in terms of hardware that you require, and then there's obviously a lot of 3D printed brackets that you need for each version. So what do you need to build each version? So that to some degree depends on which one you build, but you will always need some kind of these upper rear I/O brackets, and you can choose freely which version you want. They will fit with all the different versions. I'm gonna build with a rear 120mm fan today because I have an internal power supply plan for this demonstration build. So you will need one kind of upper rear I/O bracket. Because I have an internal power supply, I have this standardized internal SFX bracket. This is very flexible how you can mount it. It has many different potential mounting positions, but you will see that I'll demonstrate it quickly later. You can also play around with this once you build your own to see what fits or suits your needs. Many options. Then I will also, as I mentioned, use this 3D printed upper beam replacement because I don't want to use the aluminium version. So these parts that I just showed, they would work with any version. If you use the ATX, micro ATX, 2-slot ITX or 3-slot ITX, it doesn't matter. These parts would work with all of them. And then the next parts kind of define which version you're going with. So right here I have the parts printed for either a 2-slot ITX version or the 4-slot micro ATX version. So as you can see, they're essentially the same parts, just different sizes for the different mainboard versions. So for the 2-slot, this is the lower, and then we have the mainboard beams, the lower beam, and then this is the PCIe cover here. And it's basically the same for the micro ATX version. These are the mainboard beams. Then we have the lower bracket. We have this bracket that is the lower beam replacement, and then we have the I/O cover. So these parts are essentially the same bracket, just for different versions of the case. And what these do, they make up the difference between the 200mm Makerbeams and the actual case size. Because the case is not exactly the 200mm Makerbeams in height, obviously. So these brackets make up what it actually is. The reason for that is that you don't have to cut custom lengths of profiles. So these do the same thing, and because the micro ATX case is taller, this makes up for that. You will see later where exactly these come in. Then we have this, obviously, this panel that I mentioned earlier. So this makes up the actual slots and rear height. These are the beams where the motherboard secures to. So this is one on the rear and this is the next one. For ITX boards you only need two, because they are small and they are narrow and they only have 4 mounting holes. And then for the micro ATX versions and for the ATX version you will need 3 beams. You can actually see they're numbered here at the bottom. It says 1, it says 1, 2, 3. For micro ATX and ATX you will need 3 beams because there are more holes. Those are the ones you need for micro ATX. And then we have noticed on the ITX, on this beam, these 4 holes you see here. So these are the holes the mainboard screws to, obviously. And then you can see these 4 holes here and these 4 holes here. These are important so the outer panels can be split, because the case gets quite tall and then you might not be able to print the full height of the side case panels. These places here where nuts are inserted are used to split the case panels. That might not be that easy to understand, but I'll just demonstrate in a minute. So obviously I have the 2-slot version here and I have the parts for the micro ATX version here, and I'm gonna build the micro ATX version today. Now before we start assembling the parts in case, we first have to prep the parts by inserting M3 nuts in various locations. You can see it here, for example. Here they are already inserted. So normally I just press them in and then use these pliers to press them in all the rest of the way. Now I have prepped most of these parts already, and you can see them here already. Then they are located here on the inside. There are a lot in this lower bracket here because it connects to the the upper rear I/O bracket, and then there needs a lot of screws for it to be securely in place. Then you need to put them here in the back of the mainboard beams. I have added them here already, and I have not added one here, so I can just quickly demonstrate how I would add them. So I will just take one screw, press it in as well as I can. Depending on how your printer setup is, it might go in smoother or less smooth. This is a bit tight now, and these nuts are actually quite a bit recessed. So what I do is I add a small screw, and then I use the pliers to press it in all the way. So, and once it's pressed in all the way, I remove the screw, and now it's nicely recessed. Not all nuts are recessed like this, but a lot of them are, so you will probably have to do that for most of them. But I have prepped basically all of these parts. I have not added the nuts here. If you want to add case panels or the split case panels, you have to add the nuts here as well. I'm not going to add case panels to this build today, so I'm just going to leave those off for now. So now I'm going to start assembly. The first step is to combine this lower rear I/O bracket and the upper rear I/O bracket to make it one unit. So for that I just simply slide them together as I did now, and then we need to add screws in specific positions. As I mentioned before, you will only need countersunk M3 and countersunk 8mm and 60mm screws, and that's all you also need here. So here in the top it's gonna be 8mm screws, and here on the side it's gonna be 60mm. Now I've not tightened these completely yet, because I want to make sure that everything is nice and flat and aligned. So I'm gonna press it down on the table a bit to see that everything is nice and flat, and then I'm gonna start tightening them completely. So once it's screwed together, it should be very secure. You can actually tighten them even a bit more. Now you should not over tighten these, because at some point you can split the plastic, but they will take quite a bit of torque. Yeah, and now it's secure. There's still a bit of flex like this within the bracket, but with everything assembled, that should help reduce the flex in it once the case is fully assembled. So next step is actually taking this first mainboard brace and connecting it to the rear bracket. These parts are connected to add extra stiffness and strength to the frame overall. There are positions where the screws go through, and there are nuts here that are already installed which take the screws that go through there. So this guy slots in like this, and then two 8mm countersunk screws go in here, and the parts can be connected. Now that these parts are screwed together, we can already start adding the Makerbeam XL profiles. So for that I'm gonna already insert like some 8mm screws and M3 nuts here, because it makes it easier once you slide them in. Now I'm gonna do that for all of the mainboard beams, so I can just all of them slide them just into the Makerbeam XL profiles. Now once you have these like loosely screwed in, it should look like this, so that they shouldn't be tight, there should still be a little bit of space, so they can easily be slid into the Makerbeam profiles, which I'm gonna do now. So for that we use the 300mm long ones for length. So I'm just gonna start by simply kind of sliding them over these. Sometimes you have to align the nuts a little so they slide over, but normally it works fine. So once you have these kind of secured here, you can use 16mm screws through the holes here at the back to secure it to the back panel as well. So once this is secure, we can slide the other mainboard beams on, obviously in the corresponding order. So 1 is the lowest one and then 2 is the second one. So once you have come to this point, then these are still, I have not tightened them fully, they're still loose, I can still slide them around. And to get the correct spacing between these right, there's a bracket included in the files which just has the correct hole spacing, and you can print that out and then you can align them correctly. So that's what I'm gonna do now. Now all the mainboard beams are aligned and we could theoretically already mount a motherboard, but I'm first gonna complete the case. There's actually not that much left to do that. So I'm first gonna add the other 300mm beams here. Now the case is already taking shape. Now for the height we have these 200mm beams, but as you can see the length is not enough, so that's where this bracket comes in. It basically makes up the remaining height, so it's long enough. Theoretically you can also get custom length so it fits perfectly, and then you can use the aluminium beams on each end, but then you would have to order them custom cut, and not everybody can do that, and it adds costs. So that's why there's this 3D printed bracket that makes up the remaining length to get it to the right height. And obviously this then is not as flexible as these, but this still gives you a lot of options by having the beams up here, and adds a lot of strength over the overall distance. One other thing I want to mention now, I'm not gonna add really any accessories to this frame now. But if you would add case panels, fan mounts, all sorts of things that require nuts in these profiles, then it's a good time to add this now, because you can slide the nuts very easily into the frame now while it's not complete yet. And yeah, it makes it very easy to add the nuts. You just slide them in and then you have them in there, and then you can position them once you need to add the accessories. The best way to do it is to have like some of these nut positioners. I now use the ones for the flat, and then you can just slide them in, and these keep them in position, then you can position them for later. So if you wanted to add case panels, then you would need 1, 2, 3, 4 here, 1, 2, 3, 4 here, 1, 2, 3, 4 here, like basically all these outer sides you would need 4 nuts just for the case panels. And then whatever you want to add here on the inside, that also makes you have to, normally I add some on the inside just in case I want to add something. If you want to adjust it later, it's not that difficult. You can just take off the bottom or this top piece here or front piece and just add more. So it's not, if you forgot some, it's not critical, but this is a good step to add them, and then they're in there just in case you need them. It's also actually a good time to add the SFX PSU bracket. So this is a very universal bracket, and you can add it in many different ways. But for the micro ATX and ATX builds, the best position to add it is kind of here. So this way it sits directly in front of the motherboard. So if it's there, then the power supply would be here. There are also other options. You can mount this in many different ways, especially for the ITX version, because there you can also add it like this, because the ITX motherboard is short enough. But yeah, basically it can be positioned in many different positions. You could theoretically also add it like this or like this. Like there are so many different positions for this bracket. It's very universal, and you can kind of just try and play around with it. And depending on your hardware config, there might be different places where it might be better positioned. But for this build, I will just add it here. And if it's there, this is the top of the case more or less, then it's right in front of the motherboard, and it just barely fits there. And that means that there's all this room here for activity, for example, for a large air cooler. But as I said, you can add this like this for the ITX versions, for example, and this bracket is very universal. You can mount it in many different ways, which is one of the nice aspects of this system. But I'm just going to add it like this, and I'm going to already install some 16mm screws and then nuts, and then just slide it in. So now I can screw it in like this, and you can use standard M3 nuts here at the bottom and just slide it in. But what I tend to use is some of these flat nuts with these nut positioners, and I'm doing this so if I want to take it out later, I can do that and the nuts won't slide around. If I just use the standard nuts, then they will slide around, and it works as well. From a structural perspective, it's the same, but then they can slide around here if I, for example, tip the case. So now I'm just adding these ones with the small plastic part that don't slide around. So, if you're using this beam, then it's better to first secure to that and then slide it in. But since I'm gonna use this 3D printed replacement, I'm first gonna secure it in place, and then I can later attach it to that. Yeah, so now that that's in place, I will attach the 200mm long beams by first using this 3D printed replacement. The 3D printed replacement just uses 8mm screws in the corners to screw into the aluminium profiles, and that these holes are sized so standard M3 screws will thread directly into them. When we secure this SFX PSU bracket to this beam, the screws just go through here and screws right into the plastic, which is not the strongest option, but it's plenty strong for this. So now the only part missing is this one, and the screws that go this direction are only the 8mm long ones, but the ones that go down like this should be the 16mm long ones, and in order to secure those you need a screwdriver that obviously goes deep enough into the hole. So if you have a bit screwdriver, it probably won't fit in there. This is only really a problem in the micro ATX version. On the 2-slot ATX version and the ATX full ATX version, all of these are much shorter. It's only the micro ATX version that has this deep screw slot hole. So for this one it's kind of necessary. On the other one it's not as critical, but you can also see that in the 3D files. So with that, the basic frame is already assembled. As you can see, it's really basic right now, but that's kind of the beauty of BeamCase SFF. You can add more parts and more brackets and fans and all that with different add-ons. In this stage, it will really only hold the motherboard, the graphics card and the power supply. There is nothing else. And besides adding brackets for fans, you can also add brackets like this X brace here for strength. So this will stiffen up the case a lot, especially if you add them all around, and will help with the overall rigidity of the case. In this base config, there's still a little bit of flex, as you can see. It's not a lot. It's overall very strong, and I'm very confident in the case. I'm putting all my force in there to twist it. But you can make it even stronger with X braces like these. Brackets like this you can just find on my Printables profile. So now I'm already gonna add some hardware to just show you how to mount things. But I'm not gonna put a full system in this case in this video, primarily because all my parts are kind of used up in other systems. But I'm just gonna show you how you add like a motherboard, an SFX PSU, and how you mount the GPU. Mounting a GPU is quite different to other cases and has changed with this case iteration. Now for this case, I'm just gonna demonstrate it with an SFX power supply, a 3070 Asus TUF, and this micro ATX mainboard, just to demonstrate how to mount the basic components. But the cool thing about this case, it's fairly compact and it will fit a Noctua NHD15, a full big size CPU tower cooler, which makes it quite unique. And now I have configured it with 300mm beams for length, and that means it will fit around 350mm long GPUs. But if you wanted to fit a larger GPU, you could just use longer case beams and make more space that way. This mainboard has an integrated I/O shield, so don't have to add it, but I just plop it in through the top. So now to actually mount it in place, we use 16mm screws, but just the 16mm screws would be too long. So we are also using these 3D printed spacers that are included in the files, and they just go over the screws like this, and it means that they're the correct length, and the spacer also distributes the force nicely on the motherboard, so it's not centered in one point. So yeah, I can just use these and then plop them in here like this. I just slot them in and they have a fairly loose fit by default. And then you can, once I have them all kind of loosely slotted in, I will tighten them, and that way makes sure once they're all loose in there that they're all aligned, and then I can tighten them to keep the mainboard in place. And now the motherboard is secure in place. I didn't mount the cooler now, but I probably would have mounted the cooler mechanism before I've mounted the motherboard, because due to the size of the 3 printed beams, you don't really have great access to the back of the motherboard after you've mounted it. It's simply due to these have to be a bit thicker than if they were out of steel or aluminium or whatever other material. So that's when I would, if I mount the CPU cooler, I would mount the mounting beforehand. Yeah, so the mainboard is already secure, and then in the next step I'm gonna mount this GPU. This one is 300mm long, so it's fairly close to the maximum size of this case configuration, so I'm just gonna slot it in like this. So now it's slotted into the mainboard, and instead of putting screws here through the top, these nuts that are located here in the rear I/O cover squeeze it into place. So I'll just slot this in. And then 2 60mm screws where the graphics card is mounted. I'm gonna put those through here and then tighten them to secure the GPU in place. And depending on the size of your screwdriver, it can be better to just flip the case upwards for that. Like this. So now I can just add the screws through here. So, and this way the GPU is clamped between this PCIe cover bracket and the frame, and it's very secure, it doesn't move now. And if you have multiple GPUs, then you would obviously do this clamping step at the end, or if you have other add-in cards. And I would also advise to only add screws where the PCIe slots are actually populated. Like, it's not necessary to add another screw here. If you do that, you will just bend the frame with the torque you apply to it. Only add it where it actually clamps metal in place. Yeah, there's also then an optional screw here at the bottom, which can be used to secure the PCIe bracket on the lower end. It's not necessary, it's optional, you can use it. I'm gonna add it now to add a bit more stiffness to the frame overall. With that, the GPU is already secured in place. I will probably at some point create brackets to support GPU sag, but it's also very easy to create your own, or to use the anti-sag holes that most GPUs have to support the GPU as well. Yeah, so as you can see, this is fairly compact. Here at the bottom there is a little bit more space between the motherboard and the frame rail, as you can see, and that's so you can add 140mm fans here at the bottom for intake. There's still enough space for that here, or if you have a very thick GPU, that will fit as well now. So, and then I'm just gonna add the SFX power supply now. There is enough space here to add an SFX power supply as well. And for that we use these kind of special 632 UNC screws that I mentioned earlier, and we only need four of those, and we can simply position it like this and then add the screws. So once these are tight, the PSU is extremely secure. I can lift the whole case just from the PSU. It's very important to me that this is very strongly mounted, so if you travel, it's still very securely in place. And now really, as I mentioned, I'm gonna put a complete system in it, but one of the steps that still has to be done, that I still want to show off, is how you add the clamp-in style extension. So depending on the rear bracket you have chosen here, there will be different options for internal PSU extensions, but this is the one I primarily use, where it's doesn't have any screws and just gets clamped here in place. So this one goes down like that and fits here in the top. Like this, simply plug it in, and then it will just squeeze through here. And then this is obviously not 100% tight now, so there's a slot for 16mm screw here at the bottom, and this just squeezes this bracket down here so this plug is really securely in place. Yeah, and once this is quite tight, then there's no way the plug can slide out or in. And you may wonder why the plug here is at an angle. Now this angle is very crucial if you have an ITX build and you use a large air cooler. For me, the Noctua NHD15, if I had it at an angle like this, it would just about go over it. If it would go straight, it would go straight into the NHD15. This angle makes sure that it kind of goes under large air coolers, yeah. And then kind of you can sneak it along here at the top into the power supply. Now the last step to demonstrate is adding the 16mm power button. There will probably be options to add it to the front as well, but the one at the back here is a nice location because it will probably work on any config of this case. So I like to position it there because it's a universal position that will work with any build. And that basically kind of completes the rough assembly here. You can also add more brackets to this, fans here at the bottom, fans at the top, fans at the side. There are a ton of brackets available on my printable profiles. The additional brackets don't cost anything, they're all free. It's just the basic frame where you need to purchase the files. Also helps me a lot to buy more components and test more case variations. This is how it looks right now. Very simple, very basic. And this frame for a micro ATX case is actually super compact. Even though it supports a large air cooler, I think this is it's around 17 liters in size for the micro ATX version, but you can also check the Printables profiles for exact measurements. Now, as I mentioned earlier, all these components for the micro ATX version will actually fit on an Ender 3 style printer, so they only need a print bed that is 220mm long. Now, these parts here are obviously longer than that, so you need to print them diagonally across at 45 degrees across the print bed for them to fit on the print bed. Very easy, it's not a problem. But then obviously to print case panels, you wouldn't be able to print case panels that are the entire height. Actually on my P1S I can't print them either, they would be too tall because they would have to be 290mm long. So because of that we have these screw positions here in the center. And the case panels with the BeamCase version 5 update and the ATX and mATX version, they can be split like this. So they don't have to be dual color, and the bottom one can have vent patterns as well. This one is just solid now, but it's just a demonstration on how they screw in then. And you can see here, that's why these 4 holes are here. So you can secure the case panels, the split ones, and then each side is made of 4 case panels, which is a lot. but this way it can be printed on smaller printers as well. And this same construction method will also be on the new SFF version. You don't have to split the panels, you can also print them in one go if your printer is large enough. But I have made panels available for all versions that are split, which means you can also print the ITX version on an Ender 3 completely. And where the split is really necessary, if you print the ATX version, because it's a substantial amount taller, and there are very few printers which would be able to print the ATX panels in one go. So that's why I put a lot of time into engineering the split for all the versions. Now obviously we have this screw point here, but on the other side there is nothing right now. So if you would put it here, it would be flippy floppy right now. So for that there are different options to add support. All of these are options to add support here in the center. As you can see, it has the same shape, so you can have this style, which is the lower support, and then just comes up from the bottom like this. Or you can have a full height support, which is the strongest option, which then adds the support, which goes from all the way from the bottom to the top. And then there's also one that just goes from the top like this, in case you want to have space for mounting stuff here at the bottom. And then theoretically you can also just connect the panels with this simple bracket here like this, and so there's nothing attached to the frame, and connect the panels like that with this bracket. Obviously that's not as strong if you also have it connected to the frame, but it's totally an option as well, and makes it a bit easier to mount all the panels, I want to say, or makes it a bit, you don't need to add anything to the frame then. For each case version there will be these parts that support this one goes like this, that support also the case panels, and these are obviously different depending on the case versions, but it's all added with the corresponding heights. So this for the ATX version, this would be taller, for example, for the ITX version this would be smaller. But that's how this case can be entirely enclosed, even if you don't have a huge printer. Engineering this took quite a bit of time and thinking about how it would work, and that's why this ATX update also took a while. And regarding this whole thing, you may see these holes here at the end in this rear I/O bracket, and these holes between those screws are also to secure the case panels here. So it's also secured on this side, and it will also be secured on this front side here. And you need 60mm screw to screw in here, but I'll probably make another video dedicated to how to enclose this case. Yeah, but this is just so you know, if you want to enclose it, then you will have to add some kind of support to connect these 4 panels, and then the front panel will also be out of 2 pieces, and all of this means that this entire micro ATX case can be printed on an Ender 3 style printer with only a 220 by 220mm print bed, which should make it possible for most people to print this. If you have one of these tiny printers, I want to say, with a print bed of 180 by 180 like the Bamboo Lab A1 Mini, this is not gonna be, you can't print it on this, because it's just printing within those requirements is just too tough. But now you can print it on an Ender 3, where before that wasn't possible. Yeah, that's kind of it for this frame. Now this is the micro ATX frame, as you can see. So now I'm also going to demonstrate how a complete system can look. This is a full ATX case. This is a system I have fully built, and this is done with a full ATX motherboard. I only use a single GPU right now, but this could even run a dual GPU build. I have a 120mm rear fan as intake, power button. It's basically, as you can see, it's just a taller version of the micro ATX one, and yeah, and now you can just imagine the ITX versions just have even less slots, are even lower. This one is fully enclosed right now, as you can see, and here you can see what I meant with splitting it 4 pieces. Each of these case panels is 1 piece, and because it would be impossible to print the whole height for me, and this way I can print it on medium-sized printers. And in this case I have, I'm not sure if it's visible, In the front I have an SFX L power supply, and the rears. And this case has a Noctua NHD15 in it. I'm gonna show off the internals a bit. For that I need to take off the case panels. Now you can get a glimpse into the system. As you can see, this is a Noctua NHD15 Chromax. It's just a black version of the NHD15. I have a 120mm fan as rear fan as an intake here. I've added a shroud that kind of guides the air over, and then I have the support bracket for the case panels here coming from the bottom. Here's the SFX L power supply. I'm also gonna quickly show off there are also fans in the bottom. So now here at the bottom you can also see the 140mm fans that I added. The brackets for this are also available on my profile, and then you can also see how little space there is between the bottom of the ATX motherboard. It's just barely enough space to connect fans and any other things you want to connect at the bottom of the motherboard. And it's the same level of clearance on the micro ATX version, where you can also just barely fit these 140mm fans in the bottom, and they are great because they obviously push a lot of fresh air directly into the GPU, and as you can see there's quite a lot of space here. So for if you have a single GPU build, in most cases the micro ATX version is the way to go. I just had this ATX motherboard here, but yeah, this is kind of a demonstration of how much space there is. You can see the bottom fans. Theoretically you could also add a fan in the front, but that's only if you have enough space with your GPU. This GPU goes quite far, so there's not enough space for that anymore. There is the option to do 240mm radiators here in the bottom. 281 won't fit. It's slightly too long and it will also interfere with the motherboard because then that goes too far up. But a 240mm will fit. In the front, theoretically a 280mm radiator could fit. Obviously that power supply would have to be moved somewhere else. But basically there's a lot of options in terms of coolings with the system. It's a very modular case. You can move things around, you can move the power supply to the back and somewhere else. And this is one setup for it with a large air cooler, but you could also theoretically add water cooling options. Because the case is so modular, it's very easy to make it fit your requirements. This is just example, so you can see how it looks. So this was an update for BeamCase SFF, the version 5. I now mostly talked about the micro ATX and the ATX version, but basically anything I did here also applies to BeamCase SFF version 5. It's just a little bit smaller and just one mainboard beam less and a smaller mainboard, but it's the same concept. Both BeamCase ATX and BeamCase SFF rely on the same structure. They are separate files though, so if you bought the BeamCase ITX files already, the version 5 update is totally free for you, you can just use it. BeamCase ATX are separate files which you can buy separately, and the files include all the brackets to build a frame and then also all the parts for the case panels. So to enclose it, all the files are included in there already. I also added steps for the case panels, so if you want to adjust them with your own motifs or something, you can do that as well. The SFF version 5 will also have included all the case panels, and then accessories like the fan brackets are separately on my profile for free. There is also alternative case panel versions for BeamCase SFF, and those are still compatible with the version 5 of the case, so you can still use those. And I'll probably create more case panel versions in the future. These are kind of the ones right now, which are also very similar to the sandwich style case I built. I hope this video helps you assemble your BeamCase ATX or BeamCase SFF version 5. Putting this update together was quite a bit of work, and I'm also sorry for my voice, but I'm still a bit sick, but I didn't want to push this video any further into the future. Yeah, I hope this helped you. If you have any questions or comments, you can put them down below the video. The files for these cases are on Printables. that's kind of it. There's also a sandwich case, which is much smaller than these, which is also available on Printables. I'm really happy to finally release the ATX version. The reason it took so long was that I really wanted to find a way how to split the case panels and still screw them to the case reliably, and also how to split the rear reliably while maintaining all slots. This should really work with basically all motherboards. If you have a very large backplate, it might interfere, but I think it should be fine in most cases. One thing which is really cool about these cases is that they are very light. This whole case here weighs less than 1.5 kilograms if I remember correctly. The whole build, this whole ATX build, it's under 9 kilograms. It's very close to 8 kilograms with a single GPU, so this makes this actually even an option for travel. And even though this full ATX case looks a little bit on the bigger side, with the case panels it's 22 liters in volume, and it will still easily fit in my carry-on suitcase. So I can still take this one with me, but to be honest, in most cases the micro ATX is a better option. Unless you run a dual GPU build, micro ATX is probably nicer. You still have the benefit of having like a bigger motherboard with more USB ports, which most modern ITX boards don't have a lot of USB ports. You still have 4 RAM slots, but it's not as big as the full ATX version. So I hope this video helps you. If you have any questions, just ask. The files for BeamCase ATX and mATX are already uploaded and available now, and the version 5 update for BeamCase SFF will be uploaded and published very soon. It might be already uploaded when you watch this video. And also big thanks to everybody who already bought the files. It helps me a lot to buy new hardware and test new coolers, and obviously build more cases. I have spent a lot on screws and aluminium profiles now. Yeah, so thanks for watching and have a nice day, and if you decide to build one, have fun building one. Thanks.